this time we want to differentiate this function here, y is equal to e to the power of sine x. Now, we have our rules for differentiating e to the power of x, a function, and when we differentiate e to the power of x, we get e to the power of x. But this isn't quite that. This is e to the power of sine x. So we're going to have to use the chain rule here, because we've got two functions combined together. The first function is the sine x function, and the second function is the e to the power of function. So let's rather than write y, I'm going to write f of x. So I'm going to say start off by saying let y equal f of x. So then this question becomes, we start off with f of x is equal to e to the power of sine x. I prefer to use the function notation. So we got two functions. The first function, let's call it h of x. So h of x is equal to sine x, this function up here, and then let's say g of x is equal to e to the power of that. So, but that is h of x, so e to the power of h of x. And it's easy to differentiate each one of these individually. So h dash x is equal to, well, sine x differentiates to give us cos x. That's cos x, and then here we go, g dash x. So when we're differentiating e to the power of one thing, remember a function, this is just one thing now, e to the power of x. So differentiate e to the power of hx, we get e to the power of hx. So e to the power of h of x. And now I can fill in what h of x is, so I get e to the power of, well, h of x is sine x. Sine x. So then, by the chain rule, f dash x will equal h dash x times g dash x. So f dash x, this differentiated, will equal h dash x, it's cos x, multiplied by e to the power of sine x. E to the power of sine x. And that's it. There's nothing we can do to tidy that up. Okay, let's have a look at the second question. So this is a little bit trickier. So, but it's not too bad actually. It's pretty straightforward. We're going to have to use the chain rule, and the question is saying show that the equation of the tangent to the curve. So when it says show that the equation of the tangent to the curve is this, really it's saying find the equation of the tangent to the curve. So the equation of a tangent to the curve, we know, well, the equation of a tangent is y minus y1, tangent is a straight line, is equal to m by x minus x1, where x1 and y1 are points on the line. So we know that x is 0, but we don't know what y is, and m is the slope. So we have to find the equation of the tangent at the point when x is 0. So when x is 0, we need to find out what y is. So let's do that first of all. So we have x is equal to 0. That means that y is equal to, when x is 0, y is equal to e to the power of, well, just fill in x as being 0 up here. So e to the power of 0 all over 0 plus 1. So I guess e to the power of 0 over 1, and 0 over 1 is 0. So I get e to the power of 0, and anything to the power of 0, you should remember, is 1. So when x is 0, y is equal to 1. So this is our x1 and y1 part. So let's fill them in here. So we have y minus y1. So y1 is 1, is equal to m, the slope, we don't know that yet, by x minus, and then x1 is 0. So x minus 0. So we have y minus 1 is equal to mx, and then m by 0 is just 0. So we have y minus 1 is equal to mx. We need to find out what m is. M is the slope. Now, you got to remember that the slope of the curve, so here's the curve, the slope of the curve and the slope of the tangent at a point are the same. So in order to find the slope of the tangent, the value of m, we need to find the slope of this curve, and then at the end fill in x equals 0. So let's do that. So we take, we have this, y is equal to e to the power of x all over x plus 1, our curve, and we need to differentiate this. We need to find dy over dx, which is the slope of the curve, which is also the slope of the tangent. So in order to differentiate this, well, we're going to use the rule for differentiating e to the power of x, this rule here. So e to the power of x differentiates to give us e to the power of x, but it's not quite that. We're going to have to use the chain rule, because we've got e to the power of, this isn't quite x, it's something else. So we got a second function up here. So our first function, let's call our first function, we'll go, let's say h of x is equal to this part here, so x all over x plus 1, and then let's say g of x is equal to e to the power of h of x e to the power of h of x. Now, we need to differentiate each one of these parts here. That's how the chain rule works. So, but in order to differentiate x over x plus 1, we're going to have to use the quotient rule. So, we need to find h dash x, but hey, to find h dash x, I need to differentiate this, but to differentiate this, I need to use the quotient rule. So I'm going to do that. Let me see. I'm going to do that. I'll come over here to do that. Just want to do it out of the way, and then I'll bring the answer back over here. So let's say, okay, we've got our function h of x is equal to x over x plus 1. So then, by the quotient rule, we've got two parts. We've got the top part and we've got the bottom part. So u of x is equal to x. Now, if you don't know the quotient rule, if you can't remember, if you go back to the quotient rule videos, so v of x is x plus 1. So u dash x, differentiate x, I get 1. V dash x, differentiate x plus 1, I also get 1. So then, by the quotient rule, h dash x is equal to, it's v, this, times u dash x plus minus u times dv dx all over v of x squared. So it's x plus 1, v of x times u dash x times 1 minus u of x, which is x, times v dash x, which is 1, all over v of x, which is x plus 1 to be squared. So to tidy that up, we get, okay, we have x by 1 and 1 by 1. So we have x plus 1 minus x over there, all over x plus 1 squared. And then what will that turn out to be? Well, we've got x minus x, so that's 1 all over. And don't worry about squaring the bottom part, x plus 1 squared. Just leave it as x plus 1 squared, that's fine. So when I differentiate this quotient, this is what I get. So let's bring that back over here. So h of x is that, h dash x is 1 all over x plus 1 squared. It's just tidier when you do this out of the way, when you do it over here, and bring the answer back over. Okay, so remember what we're trying to do. We're trying to differentiate this function here, but we had to use the chain rule. So there's our first function, x over x plus 1. When I differentiated that, I got that. And g of x is e to the power of h of x. So when I differentiate that, I get g dash x is equal to, well, differentiate e to the power of, let's have a look. When I differentiate e to the power of x, I get e to the power of x. So when I differentiate e to the power of hx, I'm going to get e to the power of hx. So e to the power of h of x. And then fill in what h of x is. So that's e to the power of x over x plus 1. And then by the chain rule, dy over dx, so this differentiated, so dy over dx will equal h dash x times g dash x, so it'll equal 1 over x plus 1 all to be squared times e to the power of x all over x plus 1. So this multiplied by that. Now remember, we want to find the equation of the tangent at the point when x equals 0. So we want to find out what is the slope when x equals 0. So the slope is dy over dx, which is this here. So when x is equal to 0, what is dy over dx? So x equals 0, dy over dx will equal, just fill in 0 into this. So it looks kind of nasty, but it's not really. When I fill in 0, it'll turn into something quite simple. So we end up with 1 all over 0 plus 1 all to be squared times e to the power of 0 all over 0 plus 1. So we get, what's that? 1 over 0 plus 1 squared. Well, 0 plus 1 is 1. 1 squared is 1. So we get 1 over 1, which is 1. So I told you to simplify down into something easy. And then we get this 0 over 0 plus 1 is 0 over 1, which is 0. So we have e to the power of 0, which is also 1. So we get 1 by 1, which is 1. So the slope of this curve, when x is equal to 0 is 1. Okay? And the slope of the curve is the same as the slope of the tangent. So we can come back over here. This is what we want. Remember, a tangent is a straight line. So we want to, so here's the answer, but we needed to know what x1 was, what y1 was, and what m was. We figured out that x1 was 0 and y1 is 1. And then I just need to fill in m now. So the equation of the tangent, y minus 1 is equal to, we know m, the slope is 1 down here. we figured out. So 1 times x, or I can write that as y is equal to x plus 1. And, go back up to the question, it said, show that the equation of the tangent to the curve y is equal to e to the power of x all over x plus 1 at the point when x is equal to 0 is y is equal to x plus 1. And it is. That's what we got.